Hello, friends. Welcome on board, and thank you so much for tuning in. I'm always glad, sorry, to do these presentations for your benefit. Now, today in this session, I would want us to look at a common problem that is asked in calculus, that one of sketching a curve. So, like what we have here, we are asked to sketch the curve whose function or equation is given as y is equal to x squared minus x minus 6. This is actually a quadratic function. Now, when you're asked to sketch, of course, as the name suggests, accuracy is not the major interest in this case. And that notwithstanding, you are supposed to, in your sketch, show certain salient features of a curve, what I also call the important features, the salient features of a curve. And there are 2 or 3, let's see. And the first one is that even when you are asked to sketch a curve, in other words, you are not given a graph surface, so you are not expected to draw on an accurate scale in the x and the y axis. You still have to show these salient features of the curve. And one of them is the x-intercept, where the curve cuts the x-axis. That is, if it does, because we also have instances where a curve does not cut the x-axis. 2, the y-intercept, that is where the curve cuts the y-axis. And 3, the turning points. Turning, or what are also referred to as at times stationary points. Stationary point. And they could be one or more depending on the curve. So we could have stationary points. And after finding the turning points, you also need to tell their nature and their nature, if they are more than one, or its nature if it's only one. Now, in a short while, we will show what we mean by the nature of a turning point. So let's embark on what we have here. So let's begin with, for instance, let's start with the x-intercept. Now at this solution, at x-intercept, what we should be aware of is that the value of y is equal to 0. So substituting in our function here, equation here, therefore we'll have, 0 is equal to x squared minus x minus 6. Okay, so we are to find the value of x when y is 0, and that will give us the x-intercept, or intercepts if there are more than one. So in this case, using this is a quadratic equation that we have to solve. So if we say, you can use any appropriate or convenient method to you for solving a quadratic equation. I normally advise that the fastest and the easiest way to solve a quadratic equation is by the method of quadratic formula. So you can check your quadratic formula from your tables. So if we substitute, we'll have, in the quadratic formula, we have negative b. In our case here, negative b is negative 1 here. So that is negative of negative 1, which is positive 1, plus or minus square root of b squared, which will now be 1, minus 4ac, minus our a is 1, and our c is negative 6. So minus 4 times 1 times negative 6, that is plus 24. Everything over 2a, our a is 1, as you can see here, so over 2. So what do we have here? The value of x is 1 plus or minus. This 1 plus 24 is 25. Square root of 25 is 5. So 1 plus or minus 5 over 2. So what does that leave us with? X is equal to 3, or that is if you take positive 5 here. 5 plus 1 is 6. Then 6 divided by 2 is 3. Or x, if we take negative 5, it will be 1 minus 5, which is negative 4. And negative 4 divided by 2 is negative 2. So the x-intercept is at 3 and negative 2. In other words, the coordinates of the x-intercept is at 3, 0, and so the curve cuts the x-axis at 2 points, negative 3, 0 and negative 2, 0. Sorry, negative 2, 0. The next thing we need to find is the y-intercept. Now, and what do you know about the y-intercept? Correct, you are right. At y-intercept, the value of x is equal to 0. So remember, our function was y is equal to x squared minus x minus 6. So when we substitute for x in that function, so everywhere there is x, we put a 0. So we have 0 squared minus 0, then minus 6. So and 0 squared is 0, minus 0 is 0. So the y-intercept is at y is equal to negative 6. So now we know the two salient features, x-intercept, y-intercept. The next thing we need to find is the turning point. So turning point. Now when we reach this stage, we use calculus, that is differentiation. We now need to get the dy dx, the derivative of that function that we have there. That is, we get dy dx. From your differentiation, you'll know that when you have that function y is equal to x squared minus x minus 6, its derivative, that is dy dx, which is also denoted by y prime, then is equal to 2x minus 1. And the derivative of a constant, so 6 here is a constant, so the derivative of a constant, negative 6 is a constant, and the derivative of a constant is 0. Now, and one thing you need to know, that at the turning point, dy dx is equal to 0. So we get our gradient function, the dy dx is also called gradient function, and equate it to 0. Okay? So at turning point, the reason is that at turning point, allow me to use turning point, write the word turning by just abbreviation T. At turning point, dy dx is equal to 0. This is a very important concept in this case. So what we do here is now we find the value of x when the gradient is 0 at the turning point, that is. So when we equate this to 0, if you can see here our x, therefore x is equal to a half. this one goes to the other side, it becomes positive, and then you divide both sides by 2, we have our half. Now this value of x is the value of x at the point where dy dx is 0, at the turning point. So it will help us, in order to get the coordinate of the turning point, we substitute this value in the function to get the corresponding y value. So in that case, to get the corresponding value, we substitute in the function we were given, which was a half, which was a x squared, but now our x is a half, so it's a half squared, minus x, and our x is a half, and then minus 6, which when you work out, you will get 6 and a quarter, which you can write as 6.25. So the turning point, therefore the turning point is at a half, and this is negative, sorry, this is negative. When you work out this, you can confirm is actually a negative value. So negative 6 and a quarter, which is negative 6.25. So the turning point is at a half, 6, negative 6 and a quarter, which is just the same as 0.5. You can write it in decimal as 0.5 negative 6.25. That's where the turning point is. Now, we said we need to find the turning point and its nature. Now here we have only one turning point, as you can see. So how do you find the nature? To tell the nature, and by nature here is whether it has a maximum turning point or a minimum turning point. That is, whether it is curving upwards or curving downwards. Minimum when it is curving upwards, maximum when it is curving downwards. So in this case, to do that, to determining nature, we go for the second derivative, y double prime. Remember, the first derivative is what we have here, y prime. So the second derivative is the differentiation of the first derivative, which in this case now will be, if the first derivative is 2x minus 1, so we derive it, we get 2 in this case. Then the next question you ask yourself before you decide whether it is a maximum or a minimum, you ask yourself, what is the second derivative? Now, if it were not a constant, like what we have here, we would have substituted the value of x to find that second derivative. But now that here it is a constant, we don't need to substitute this value of x. So we just conclude using what we have here. So after finding the second derivative, the next question you ask yourself is it a positive or a negative? Now, the interest here is not the value. The interest here now in determining the nature is the positivity or the negativity of the second derivative. So like in this case, now, even before we conclude, if the second derivative is a positive, it doesn't matter the value. As long as it's a positive, then the turning point is a minimum. That is it. The curve turns upwards, curves upwards. Now, if it is a negative, that is, if your second derivative is a negative, the turning point is a maximum. This is a rule of thumb. It applies to all cases. So like in our case here, what do you see? Our second derivative is a positive. So our curve, our turning point will be a minimum because it's a positive. We've said with positive minimum turning point, that is curving upwards. negative maximum turning point, that is curving downward. So like in this case, our curve, when we go to our graph, our curve will be curving upwards because these two signify minimum. So now the final thing now that we are supposed to do is to go to sketch again our Cartesian plane. Again, it's a sketch. We don't need a consistent scale as long as we show the salient features. So remember, we said the x-axis, the x-intercept was at 2 points, x-intercept 3, 0 and negative 2, 0. So that means if we take 3 to be somewhere here, 3 to be somewhere here, negative 2 will be on this other side, and negative 2, 0, negative 2, let's say is somewhere here. We're just giving approximate positions. These are sketch, remember? And then we say that the turning point is at a half, what we said here, a half, negative 6 and a quarter. So if this is, let's say 1, this is 2, then you have 3, a half will be somewhere here. And then negative 6, let's say we have the y-intercept. We had seen, we had said that the y-intercept is at negative 6. Remember, negative 6 is here, the y-intercept. So if this is negative 6, if this is negative 6, sorry, if this is negative 6, and then we are saying that the turning point is at 0, you see here, negative 6.25. So negative 6.25 will be slightly beyond negative 6 on the negative scale of the y-axis. So let's say, and remember it is 0.5, the coordinate is 0.5, negative 6. So negative 6.25 will be somewhere down there. And what did we say? The nature is the minimum, because the second derivative is this. So minimum means it will curve upwards. And it's passing through the y-intercept, which you've seen is negative 6. So you draw there. And then passing through the x-intercept, which is one of them negative 2. And the other one is 3. So you do this. So if 3 is there, so your curve will be something like this, a sketch. So it will be something like this. So this is the sketch that is required, and the procedure is as I've explained. So thank you so much for watching. You're welcome to make a comment and ask any question. I'll be more than willing to respond to them. If you are new here, please make an effort to subscribe. Press that bell button just in case I upload another video, you'll be notified. Thank you so much for your audience. Bye bye, and always take care.